If you're watching this, it means that I probably had my baby. I'm hoping to be here for this lesson, but just in case, this is going to be the bonding naming chart in the notes and homework 4.3. So, switching your camera here, the cutouts that you'll want these little periodic tables, and also you'll want to cut out the table of polyatomic ions. So pause the video and cut those out for today. All right, so bonding naming chart. There's basically 4 different things we got to keep track of when we're naming. So we're going to divide this paper into 4, just straight down the middle here. That's probably and about here. So you got some quadrants, and then inside of the quadrants, you'll put your little the periodic table. I gave you 4 periodic tables, but you don't need all 4 of them. You only need 3. So one will go here in the top left quadrant. I did a bad thing there. I should have not taped so much onto the periodic table because we're going to be coloring them. And the more that I tape onto them, the less I'll be able to color them. So I'm trying to fix my mistake here. Okay, so there's my first 2 periodic tables and tape. And then the third one down here in this quadrant, the bottom right. And you would think that you would use your last periodic table. Oh, it's really bright. You would think that you'd be using this, but actually just crumple it up or whatever. Keep it in case you mess up and you need it. Instead, you'll put this one here, the polyatomic ions from last time. All right, so pause that video so that you can have your notes look like mine. Technically, all of these have names. In this section, we will do what's called type 1 bonding. We've already learned this one, so don't get scared. That's just the name. Type 1, which is a type of ionic bonding. Type two, we've already learned as well. We just didn't call it that. We called it something else. It is ionic bonding. Type 1 is the easy peasy one that we started out with at the beginning. This is the very first homework assignment for the unit. It's where we took something that was in the easy to figure out the charge column, like the 1 plus, 2 plus, 3 plus. We kind of used those. And the 1 minus, 2 minus, 3 minus columns. You put one of each of them together to make a compound. For example, potassium is like here-ish. I mean, obviously this periodic table sucks because it's blank, but potassium is here. Potassium is a 1 plus ion. If I combined that with, let's say, phosphorus, which is here in the 3 minus column, if I were to put those together, I would need to have 3 potassiums for every 1 phosphorus so that it balanced the charge. We called this compound potassium phosphide. And this was in homework 1, 4.1. One more example. We had magnesium, which is right here in this column, Mg, magnesium, 2 plus, and I don't know. Oh, I guess when I said phosphorus was here, I meant that was nitrogen. Phosphorus is underneath, but we can use nitrogen, so that way my boxes all got used. Nitrogen is in the 3 minus column. 3 and 2 can both go into 6. I'm going to need to have 3 magnesiums to counteract 2 nitrogens. The name would be magnesium nitride. And then again, as a reminder, let me see if I can find a different color pen. This was homework number 4.1, as was this one here. Both of these were homework 4.1. Type 2 is what they call it. This is the one where we had to use the Roman numerals for anything that was in this middle section that's kind of extended a little bit down there on the bottom. The transition metal region. So in the transition metal region, we had to use Roman numerals to figure out the charge. So like chromium is 1, 2, 3, 4, this one here. Not that it matters, but there's chromium. We know that the charge is positive, but like how positive, we don't know. So if I told you I want you to combine a chromium that has a 2 plus charge and let's say an oxygen, this part stays the same, right? This was our 3 minus 2 minus 1 minus. An oxygen with a 2 minus charge, you'd go, wow, easy peasy. If the chromium is 2 plus and the oxygen is 2 minus, I need one of each, one chromium, one oxygen, CRO. But this time, since we had to be told that the charge was 2 plus, because it was in the sketchy region, we will call this chromium 2, right? This is the charge of the chromium, chromium 2 oxide. If you were to make a different one, let's say that down here below, I wanted you to show me what chromium, gosh, I don't know, chromium 6 oxide was. Well, the oxygen part stays the same. It's still in the 2 minus always column. But this time, instead of a chromium 2, I'm trying to combine it with a chromium 6 plus, because chromium 6 oxide. Six positives, 2 negatives. I can have just one of the chromiums, but I'll need 3 oxygens in order to negate the charge. So CRO is chromium 2 oxide. CRO3 is chromium 6 oxide. Easy peasy charges, type 1. Roman numerals, type 2. Pause the video if you need a second to catch up. I know I'm going kind of fast, but you can always pause it if you need to write this down. So then after that, in homework 4.2, we did these things called polyatomic ions. Homework number 4.2. They're called polyatomic ions. And these were similar in that we were going to combine charges of things, but instead of just a singular atom having a charge, now we have a molecule with a charge. OH minus together has a charge of -1. CO3 together has a charge of 2 minus. And here are the names: hydroxide, carbonate, acetate. This one's written a little bit differently than what you're used to, but it's the same thing. Cyanide, nitrate, nitrite, sulfate, sulfite, phosphate, phosphite, chlorate, chlorite, and many, many more, but these are the only ones that you needed to memorize. So if I wanted to, for example, make, I don't know, let's do aluminum hydroxide. Well, hydroxide is in, it's a polyatomic ion. Hydroxide was the first one that I did right up there. It is OH bonded together. That whole thing has a negative charge. Aluminum here on the periodic table is in the 3+ column. I have a 3+ coming together with a 1-. We always write the positive one first. And you just swap the charges. We need 1 aluminum for 3 hydroxides. Al parentheses OH parentheses 3. And this was homework 4.2. We did lots of examples of polyatomic ions. The last one here is not going to be dealing with ions at all. It's going to be a new type called covalent bonding. This is type 3. This is the third one that we will encounter. So far we have type 1, type 2, polyatomic, and type 3, which is new word, covalent. Covalent bonding happens when you have some sort of a nonmetal and it's bonding together with another nonmetal. As a reminder, the nonmetals are what we've been color coding kind of in blue over here, like this sort of triangle region here. Not exact, but ish. You could look it up if you wanted on the periodic table, and also hydrogen. So if you have 2 elements coming from this section, 2 or more, they're going to combine into a covalent compound. Pause. I mean, don't really pause, but we're not done with the notes, but I do want to show you the difference between ionic and covalent before we learn how to name them. So here is homework 4.3. The interaction between 2 nonmetals is covalent. In a covalent bond, the 2 atoms will share their electrons in order for each to gain a noble gas configuration, to be happy like a noble gas. For most atoms you come across, this will mean having 8 electrons in the valence shell, the outside ring, which is called the octet rule. Okay, many of these compounds can share electrons in more ways than 1. Oh my goodness, that's the key part. Which will lead to compounds like CO versus CO2. So to distinguish between the compounds, we're going to use prefixes for the naming. So compare and contrast, we've got ionic bonding is what we had last time. This is the full transfer of electrons. And we were using the charges to determine how many atoms were present. We were saying lithium has 3 electrons, but it's going to get rid of this one. That one actually comes over here to fluorine, so it can have 1, 2, 3, 4, a full outer ring. Lithium is a positively charged cation. Fluorine, 1 minus because it gained an electron, is a negatively charged anion. And I'm not going to color this, but you do need to color this. See, it says color. It made the checkerboard pattern that we recognize as ionic. See? Like checkerboard. The new one for today, covalent, is sharing the electrons. More on this later, but essentially we need to use the prefixes to determine how many atoms are present. What I mean by sharing is that, again, more on this later, but the idea that like oxygen has 6 dots in its valence shell. It needs to have 8 to be stable like a noble gas. So what it does is it enlists some buddies like hydrogen that has 1 electron in its valence. The hydrogen comes in and they say, we're actually going to share the electrons here and here. Sharing is caring. So now the oxygen has access to 1, 2, 3, 4, 5, 6, 7, 8 electrons when it only had 6 on its own. It shares electrons in order to have 8. This is how they bond together. This picture is going to be homework 4.4. So don't get too caught up in the actual, well, wait, why did those come together? We'll talk about that. But for today's assignment, you're learning how to name them so that way we can talk about them tomorrow and be on the same page. So use prefixes to determine how many atoms are present because many of the electrons can be shared in multiple ways. The prefixes are as follows. Mono is 1, like carbon monoxide would be 1 oxide. But carbon dioxide would be 2 oxygens. I don't think it exists, but trioxide. 4, people mess up a lot on. They think it's like quad or something, but it's tetra. Penta. Hexa. Hepta. Octa. Nona. Deca. So pause that if you need a minute, but I'm going to switch back to the notes and finish up what this section has. I'm going to copy that line almost word for word from that homework. Because covalent compounds can share electrons in multiple ways, prefixes are needed. To show how many of each atom are present. There is basically one rule for this section, and it goes like this. We're going to remove the word mono if it is at the very beginning of our name. So for example, if I said, what is this molecule? And you're like, CO2. Okay. One carbon, you'd say monocarbon, two oxygens, monocarbon dioxide. Is that right, Miss Oliver? And I would say, no, it's not right. No, 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 no. Because you're going to remove mono if it's at the very, very, very beginning, like here. So we would take off that. It would just be carbon dioxide. You can keep it if it's anywhere else, but we don't want it at the very beginning. Pause if you need, but back in the homework, on this side, we have an example showing that like mono gets removed if it's at the very, very beginning. This would not be monocarbon monoxide. It would just be carbon monoxide. So here we have the formula and we're changing it into the name. And here we have the name and we're changing it back into the formula. Disulfur. Di means two. Disulfur. Dichloride. Chloride is from chlorine. Disulfur dichloride. Nitrogen, I guess it's just one of them. Nitrogen monoxide, one oxide. Dichlorine, two chlorines. Heptoxide, so that's oxygen, and hepta is kind of a weird one. That's number 7. Heptoxide. And you get the idea. The reverse is fairly simple. PCl3. I would say monophosphorus, but we always take out mono at the beginning. So this will just be phosphorus. There's only one. And 3 chlorines. Phosphorus, trichloride, because even though it's chlorine, even though it's just chlorine, we get the IDE at the end when it's bonded together. Sulfur, just one of them. Trioxide. Sorry about that. I had a guest come in. So then on this last one, it would be sulfur hexafluoride. So there you go. And all of this whole bottom of the, actually, yeah, the whole bottom here, this is covalent. So this whole section is going to be using prefixes. This whole bottom section. What's going to get confusing though, you're like, wow, this is super easy. It is super easy. It is super easy, but it's not going to be so easy when you flip your paper over, flip. And then it says mixed review, and you've got to deal with Roman numerals. You've got to deal with polyatomic ions. You've got to deal with prefixes. Like, it is all of the stuff on that page, all 1, 2, 3, 4 types all together, mixed. So you've now learned it all, but it is a little bit tricky. So what I'd like you to do is go through and next to them, somehow try and color code what section it's from. So for example, the ones that have prefixes, I would color code in blue because those are a different naming system. And this will help keep my brain straight. So like kind of skimming this, boron trifluoride, I know that that's a covalent compound because it has tri, silicon dioxide, carbon disulfide, whatever. And you can go through your page and figure out which one have prefixes. You don't have to do this. I just think it helps when you're like running back through it. Ones that have Roman numerals are really easy to tell, like what the naming rule is on that one. Like the copper 1, iron 3, stuff like that. Those ones, super easy to tell that those are going to be the Roman numerals. And then like down here, you'd need to pull out your periodic table and actually think, does copper, is that going to require a Roman numeral? Yep, there's copper. Lithium? Nope. Magnesium? Nope. There's copper again. Zinc right there underneath it, but it's right here in that same region. So if you want, you can go ahead and color code them if it helps you. If it doesn't help you, that's fine. But essentially, it is a little bit tricky because you've got all the types together. So I'll do some of them with you. We'll start at the bottom where I'm already zoomed in with my camera. For this compound, also another thing you could do is go through and highlight your polyatomics, like hydroxide, sulfate, acetate down there. Look up here. You're gonna miss this if you don't write it down. Acetate. I know this is hydroxide. It's a polyatomic ion. Hydroxide is OH with a 1- charge. Got that from a flashcard here. If it has a -1 charge, -1 charge, and there's 2 of them, then that must mean that this copper has a 2+ charge. Copper 2 hydroxide. Down here, SO4. SO4 is a sulfate. Mg is magnesium. And now I need to double check. Does magnesium, do I need to put a Roman numeral on that? And the answer is no, I don't need to, because it's in this column here that has the same charge always. It's not in that middle region. So this would just be magnesium sulfate. PCl3, PCl, both of those are nonmetals. They're in the triangle over here of nonmetals. 2 nonmetals are covalent. Phosphorus chloride, I need that prefix. Of course, you could just go through all of these and just Google them and see if Google has the right answer. Sometimes it does, sometimes it does not. You can do that. I don't care. I won't know. Actually, I might know. Sometimes Google's wrong. I'll still give you points on this assignment if it's done. I'm gonna just like assume you won't do that though, because on your test, which you can't use Google on, it'll say stuff like just like this. I just copy and paste it almost exactly, sometimes exactly from the homework. So I'll say, what is the formula for zinc 2 phosphate? And you'll have to figure out that it's this. So obviously the practice is so that you get better, not so the homework isn't worth much, right? It's worth enough. You want to do it. It's worth 10 points, 10 points, 10 points, 10 points. And then the test comes around and it's worth like 100. So essentially your homework is for learning the skills, not necessarily the pointage. But by the time you do the homework to learn the skill, you might as well turn it in and get your points. So anyway, there's my spiel. The back side of this is your homework assignment for the rest of class. It will take you a while. I recommend working with a partner, like try it on your own, do your own thing. Then once you're both done with a section, compare your answers. Don't work on it together because you might mislead each other, but do it independently and then check and make sure you got the same thing. Okay, good luck.